Dear students of A2, today we will start with the motion in a circle. If we have an object moving in a circle, like an object on a car, like a car on inside around a circle, or like the moon around the earth, or the earth around the sun. This is the motion in a circle. We know that the particle moves in a circular path, have a constant speed, but there is a changing velocity. From now on, we will use a new way by dealing with angles. We will use a radian measure. The 1 radian or 1 rad is defined as the angle subtended at the center of a circle by an arc equal in length to the radius of the circle. So when this arc is equal to this radius, this angle is 1 rad. Okay? So we can find the value theta. It's equal to length of arc divided by the radius of the circle. Okay? This is a radian measure. Now, if we take the circumference of the circle, which is 2 by r, and divide it by the radius, so we have the full angle, which is 2 by. 2 by rad is 360 degree, okay? And what about the 1 rad? If 2 by rad equals 360, if you divide by 2 by, which is 2 multiplied by 3.14, it is just 57.3 degree. So this is the definition of rad or radian. Now, since we have a particle moves in a circular path, so we have an angular speed. Angular speed is a scalar quantity, is defined by the angle swept out by the radius per unit time. Okay, it is the angle swept per unit time. And the angular velocity, which is a vector quantity, because it has a direction, maybe clock or anti-clockwise, the angular speed omega equals the change of the angle per unit time. So we have here delta theta equals S over R, which is the length of the arc divided by the radius, or delta S equals R multiplied by delta theta. If we divide both sides by the time, so we have distance over time, which is speed, equals the radius, change in angle per unit time, which is the angular speed. So V equals R multiplied by omega. Okay? Omega is the angular velocity, V is the velocity of the particle or speed at a specific point, and radius is the same. Now, what is the centripetal acceleration and centripetal force? If we have an object moves in a circular path like this, we have a force toward the center, okay, because we have constant speed but changing velocity. If we have a changing velocity per unit time, so we have acceleration. This acceleration is toward the center because the changing in velocity because of its direction, not because of its magnitude. So this acceleration towards the center. According to Newton's second law, F equals ma. So we have a centripetal force because of centripetal acceleration here. The centripetal acceleration equals to V squared over R. Okay, you have to memorize this value. No need to understand how they bring it, okay? Now, we know that V equals R multiplied by omega. And it's squared divided by R. So we have R squared, omega squared over R. We omit R with R. So the centripetal acceleration is equal to R omega squared, okay? R omega squared. The centripetal force, you have to multiply this value or this by mass. So centripetal force equal mv squared over R or mr omega squared. We have many examples of circular motion. When a ball is whirled round on an end of a string, you have a string and you move the ball like this, you can see clearly that the tension in the string making the ball accelerates toward the center of the circle. However, in other examples, it is not always so easy to see what the force is providing the centripetal acceleration. The centripetal acceleration or force can be provided by the frictional force between the tire of the cars and the ground, okay? Or maybe like the moon around the earth, we have a gravitational force. So the source of the force or what provided the force is not the same all the time. In the cars, if we moving around a circle, we have a forces toward the center. This is the force toward the center, and this is the center of mass of the driver, okay? So if we have a rotation around this circle, we have a centripetal force. Passenger in a car that is cornering appears to be flung away from the center of the circle. The centripetal force required to maintain the passenger in a circular motion is provided through the seat of the car, okay? The seat of the car produces a friction, so this is the force toward the center. Here we have a bank track, so we have a force here which is the weight, and this is the normal, okay? The component of the normal produces the centripetal force, and the vertical component of the normal is equal to the weight, okay? Even in the airplane, we have a weight, we have a lift force. Here, this plane will move in a straight line. If the pilot wants to move in a circular path, so he make an angle for the wings. So this is the upward force. This force have two components. This component equal to the weight. This component will provide the circular motion. We have this device used in laboratory. This makes a separation of solid, okay? He put the blood or anything wants to check inside and make it moving in a rotational motion. So the particles can be split depending on their masses. Here again we have a motion in a vertical circle. All the time the weight will act downward, okay? The centripetal force up is down, and the centripetal force down is up, okay? Because the centripetal force have to be all the time toward the center, and the weight all the time is downward towards the center of the earth. Here we have the normal reaction, which have different values depending on the position of the cockpit. Here we have the weight downward and the normal downward, okay? This is the weight and normal. The summation of these equal to the centripetal force, and here we have the weight downward and the normal reaction up. You can see that the normal reaction here is larger. if you subtract r minus weight, you have the centripetal force. But here we have normal and weight, which is equal to centripetal force. In both cases, the centripetal force have to be mv squared over r, okay? That's all for this chapter. It's very easy, but you have to remember how to find the value of speed using the angular velocity. See you later. Assalamu alaikum wa rahmatullahi wa barakatuh.